Hi guys, today here we are again. We are going to study and solve some exercise um, related to case number five. Number five, okay? This case number five is a like the last case for shortcut method. This is a shortcut method to find PI for higher order differential equation, okay? And here today we are going to discuss the case number five, and we are going to solve also some exercise related to this case. So just to you to understand that sometimes or some exercise you cannot you can solve by two cases, okay? And this case number five is how can I say? It is um, usually how can I say? It's usually applied for cases where you have x, okay, time g of x as a function here in the other side function, okay? So there we have f of d. When we have a function of d, y time x of d time x g of x, so we can apply this case number five, okay? This is the case in which the function, okay, of y, suppose here we have y rest, how can I say this one? Suppose here we have an dy dx raised to n plus an minus 1 d raised to n minus 1 y and dx raised to n minus 1 plus infinite sum, okay, a1 dy dx plus a0 y equal to, okay, x g of x. Okay, when we have this case like this, so this function is a function of d times y. D, like, is a function of operator d. Okay, this operator, differential operator, is applied to y, and this will be equal to this x g of x as it is. Okay, this one is like reduced in this form, so this is your function that you are getting here out there. So how to find yp? Because this function here, if we make it equal to 0, then apply the auxiliary equation, you are going to have your complementary function. But what about this one? What about this second part? The second part is found by finding yp, that is particular integral. So then today we are about to discuss just this particular integration, okay? So this particular integration for this case. So this particular integration for this case, okay, suppose you have this one, x times this guy. As you can see here, okay, this function is a function of d, and here we have this one. It is x times n function, okay? This will be replaced by g of x. And the same, here you have x times sinus of pi x, and here you have x times x Euler raised to x. So whenever you have x multiplying, okay, multiplying this Euler raised to x, so you will call case number 5 to solve the problem, okay? You have to call for emergency, case number 5, to find PI, okay? Shortcut method to find PI. So how is it? So 1 upon fd times x g of x, okay? This is g of x, so it must be into bracket, okay? Now see, x g of x. So what you have to do, just put here x times 1 upon fd g of x minus fd dash, that's derivative of this function of the operator of d, and divided by f square of d times g of x, just like this, and apply just those rules, okay? So this is not a method that you can solve, it cannot be solved itself, okay? Here you have to apply the other methods also. That's why I encourage you to go through all those methods before this video. This will be helpful for you, okay? Nice. So let us do this one, how to solve this equation. That's the point. Let us pick up the first question here, or we can solve first this question here. It's fine. See, this question here, as we can see, the first case, let me write down here. 1, it is like d square minus 2 pi d plus pi square, okay? Y is equal to x sinus pi x. So what you need to solve this equation, see, first you have to find what is your yc, okay? Your yc. If you look at this directly, you can understand that this is d squared minus 2 times d times p, then pi squared. Okay, what is this? Difference, square difference of d and pi. So this is d minus pi square. Okay, y x sinus pi x. Surely you can just do this, apply this normal formula for equation of second degree or second degree equation, and that's fine. So here yc, as this guy has the same root of pi, it will be y Euler raised to pi x, okay, Euler raised to pi x c1 plus x c2. Nice. I'll call this star. This is your yc. So what will be my yp? That's the question. Yp will be 1 upon f of d. What is f of d? It is this function. You can put them together, all of it, or you can just reduce in this form. So it's up on you. So I will put here d squared minus 2 pi d plus p squared times x sinus of pi x. Okay. Now see here, the question is, you have to apply this formula, because here you have x, then you have g of x. So whatever is happening with x will happen with x here. Whatever is happening with this function of sinus that is multiplying into x will be happening also like with g of x. Just substitute. Okay, so what you're going to have there, you're going to have, okay, this will be, okay, x times 1 by d squared minus 2 pi d plus pi square, okay, plus pi square times sinus of pi x. That is your g of x. Then minus f of d derived one time. So I have to derive this guy one time. This will be 2d minus 2 pi all upon this function squared. So this will be d squared minus 2 pi d plus pi square. All this is squared. Okay? All of this is squared. And here I will put g of x, sinus of pi x. Okay? So this is what we got here. This is what we got here. Now, what should I do to solve this one? See, here it is sinus, and here it is this function of d. This is sinus function of d. Substitute, put here minus a. Do you remember the case number 2? In the case number 2, we saw that pi square, okay, we said that a square, negative, must replace d square. Okay, so then pick this one and put here. Pick this one and put here. Just like this. So then what you're going to have, yp will be equal to x, okay, 1 upon, here it will be minus pi square. Okay, when you put minus pi square here, minus pi square here, it will be minus pi square plus pi square 0. The same, minus pi square plus square 0. So it will be what then? It will be only, will be equal to minus 2 pi d, and here sinus of pi x for the first expression. For the second one, what you're going to have 2d minus 2 pi, okay, all upon the same here. Now that this is squared, this is raised to 2, what will be? It will be, this one will be 0, this pi square will be 0, because here you put it like minus p squared, then p squared 0. So you're going to get this one squared, all of these squared. So it will be 4 pi squared, okay, and d squared. Then sinus pi x. Okay, so yp will be equal to what? Here, okay, as you can see, this will be x upon, okay, this is negative, just like this, negative 2 pi. Then here you are going to have 1d sinus of pi x. Okay, then here what you're going to have, just look at this, okay? This expression can be taken outside, so this will be 2d, okay, just like this, 2, and here d minus pi all upon 4 pi square, 1 upon d square. I will separate this one, and I will apply this guy here. Okay, now, here, is it is inverse of differentiation. Inverse of differentiation operator is integration operator. So here I have to apply integration. So if I integrate this guy, what will it be? It will be cosinus negative, cosinus pi of x negative, all upon pi. So then this pi come here, it will be minus x pi square, 2 here, minus x pi square, because this minus and this minus, positive, x upon 2 pi square. Then it will be cosinus of pi x. Here, what you're going to have. Now see, here you can just integrate 2 times, or you can just put minus pi here, put here, minus pi square in the place of d square. And it is fine, it's done. So then you get just simplify this and this. You're going to have like 2 pi square, and here d minus pi time. This one, just put here minus pi square, 1 upon minus pi square, sinus of pi x. Just like this. So here, okay, so don't know what's happening. So then here, what's going on then? What the marker doesn't want to work out. I don't know. Let me try another one. Let me try this one. Okay. Okay. So here you got to have x upon 2 pi square cos of pi x minus, then here this pi and this pi, this one will be positive, positive, then apply this to this and this to this. What you're going to have? You're going to have 1 upon, okay, 1 upon what? 2 pi raised to 4, okay, 2 pi raised to 4, then you will apply derivative of sinus, okay, derivative of sinus pi x, it will be what? If I derive this to this, will be what? Will be pi cosinus of pi x, okay? Then, this time this will be minus pi sinus of pi x, okay? Just like this. So, here you can understand, you can see that this pi and this pi and this pi will be cancelled out, pi, pi, and here we will change, and 3. Okay, this will be raised to 3. So, this will be the solution. This will be your YP. Okay? For this case, this will be your YP. Okay? I hope you can see there. Just let me check. Okay. Yeah. This is your YP. Now, let us solve for the second one. Okay? And for the second one, you can either solve by applying the case number 5, or you can solve also by applying case number 4. Okay? So we will solve this guy, both with case number 5 and with the case number 4. Okay? Just stay there. Let me just arrange this marker. Okay, so now that is charged. So this is the equation that we got here. Just for briefly explain. Here minus 1, okay, this guy came here, plus positive derivative of this one. Okay, nice. So let me see. I guess this is all. So then take this YP and add with your YC. What is your YC here? Where is? Okay, this is your YC. So YC plus YP is the general solution for this equation. Then we are done, right? Okay, so let me go for another one. Okay, for this case, here we have this expression, the second one. So, and the question is d square minus 2d plus 1 y is equal to x Euler raised to x. As we can see, this is in this form, okay? So this is in this form. Here we have x Euler raised to x. So just solve this one, okay? That's the point. How to solve? Just come here, and you have to do what? Find your yc. Your yc directly you can see this one will be Euler raised to x, okay? Raised to x, then c1 plus x c2, or c2x, it's fine. So how to find your yp? Yp, as it is in this formula, so we have in this form, so we have to apply case number 5, x gx. So whatever is happening with gx is happening with Euler raised to x. Whatever is happening with x, it's here. Just follow this formula. So what you're going to have here, so yp will be equal to x times 1 upon d square minus 2d plus 1 times g of x, this is Euler raised to x, okay? Then minus, okay, here this one, derivative of this one up, it will be 2d minus 2, and here d square minus 2d plus 1 square, right? All time, there is time by Euler raised to x, because Euler raised to x is our gx, g of x, right? So just apply here. Case number 1, just put here 1 in everything. If you put here 1, okay, you will notice that this guy will be equal to what? Will be equal to 0, this one. Why is it getting equal to 0? Look at your yc. In your yc, how many times is this guy repeated? It is 2 times, 1 and 2. So it means that I have to put here x squared, and I have to derive this term 2 times. Okay, why am I doing this? Because anytime, if I just put here minus 1 here, 1 here and 1 here, it will be 0. Okay? And if I derive 1 and add x and add x here and derive 1 time, and then I put again 1, it will be 0 again. Because here it is repeated 2 times, I have to add, multiply by x squared, then I have to derive 2 times also. Okay? So what about here? Okay? Here, you have what? You have this expression. If you put here d, 1 here, if you put here 1, it will be x squared. Okay, sorry, it will be, if you put here 1, 1, it will be 1 minus 2 plus 1. It will be 0. Okay? Then, if you derive this 1, okay, derive this 1 once again, okay, and apply, it will be again 0. Okay? So, you just have to see that here you will have to derive almost 4 times for this guy. We will check for that one. Okay? Because here, as you know, this one is repeated 2 times, so each of them will be repeated 2 times, so I have to derive this 4 times almost. Let us solve for this, then go for that one. Okay? You can split this, then derive the splitted expression, right? Let us go. This one will be yp. This will be x, and this guy will be repeated 2 times, like x squared, Euler raised to x. If you derive 2 times this guy, it will be only 2. And we are done with this. Minus, now let us pick up the second expression, minus 2. Now here, you have to derive, as I told you, we are going to derive this, we are going to make this one square 2 times, this one, okay? This will be d, okay, d square. Sorry. Okay. So this will be d minus d square minus 2d plus 1, and d square minus 2d plus 1. Okay? Time Euler raised to x. Okay. Now see, when you put here 1 time, I will do what? I will just apply derivative of this guy. Okay? I will just apply derivative of this guy 2 times. If I derive this 1, put here x, it will be 1. You see? It will be 1. So, okay, put here x, it will be 0. then derive this one time. Okay? Put here x, then derive this the one time. Let me just do this in a simple way. I will just split this guy. Let me just split them. I don't know if you are acquainted that minus 2d plus 1. Right. Okay. Now see. I will split this guy. So d square minus 2d plus 1 square. This will be d raised to 4 plus 4d square plus 1, then plus 2ab, this will be minus this and this, 2 and 2 will be 4d cubed, then plus this 2d square, then plus this and this 2 times, then it will be 4d. This is the expression that you're going to have to put there. Okay? This is the expression that you're going to put there. So yp will be x. Okay, here you can just do this one. X raised to 3, Euler raised to x upon 2, minus 2d minus 2. Then, here down, we know that, okay, when I substitute here for minus 1, or for 1, it will be 0. It will be d raised to 4 plus 4d square. Okay? Just organize this polynomial. Okay, it will be minus 4d cubed plus 2d square. Yeah, 4d square, this one. This will be 6d square, this and this. And what else? Minus 4d. And then plus 1. Euler raised to x. This expression here, if you put here 1 time, okay? If you put here 1 time, 1, here, put here 1 time 1, x. Because we know when we put here 1, it will be 0. So put here x. Then derive this 1 time. Just derive this. So I just split it to make it easy to derive. Okay? So this expression will be the same, raised to x by 2. Okay? Then minus 2d minus 2. If you derive 1 time, what will it be? It will be 4d cubed minus 12d plus 12d. Okay? Minus 4. 1 time. Now if you substitute Euler here, substitute 1 here in d. Put here 1, you get 4 minus 12 plus 12 minus 4. It will be 0 again. So it means that you have to derive again. And here x squared. If you derive this one, this will be 0. This will be 12. And this will be, okay, this will be 12. This will be 12. This is 212 square. And here it will be 24. Okay, 24. And here it will be 12d square. Will be 12d square. Okay? Now, if you derive, if you see, okay, just look at here. If you put here 1, it will be 12 minus 24 plus 12. It will be 0 again. So, come here and derive again. And put here x cubed and derive again. If you derive again this guy, what will it be? It will be 0, it will be 24, and here it will be 24d. Okay, now if you see, put here 1, this one, it will be 0 again. So you have to come here, raised to 4, then derive this guy. If you derive this guy, it will be only 24. So what I want to tell you with this, okay, from the very beginning, from here, we can just establish, we can just see that this guy, this expression will be like, will be repeated 4 times because Euler raised to x here is repeated 2 times. So as this guy is raised to 2, so this guy is repeated 2 times, Euler repeated 2 times, and this guy, this expression here is repeated 2 times. So 2 by 2 or 2 times 2, it will be 4. So here we could directly come here, okay, just from here. We could directly come from here and say that there is no need to write too many things, and say that here I have to add x raised to 4, and I have to derive here 4 times 2. Okay? So when I derive this guy 4 times, and I have to put this one x raised to 4, what will I get? This is x raised to 4, and this one, derivative of this guy 4 times, will be only this guy, like it's d of x raised to 4, and this is 4 times. So this will be 4 factorial. 4 factorial is 24. Okay, then put here 24 Euler raised to x, and that's fine. Then again, you're going to have this one. So here, as you can see, okay, then you will apply the differentiation part on this guy, this to this one. Okay, just differentiate them. So it is x raised to 3 Euler raised to x by 2. This applying this, and this applying this. This 2 and this 2 can be cancelled out. This will be 12. Okay? Just apply this differentiation. Okay? This will be 1. So this and this will be minus differentiation of x raised to 4 Euler raised to x all upon 12 plus, okay, plus x raised to 4 Euler raised to x all upon 12. Okay? Now that it is like this, so I ain't got no more space there. I will write here up. So yp will be x raised to 3 Euler raised to x upon 2 minus differentiation of this part here. First, it will be 4x cubed Euler raised to x upon 12, then plus x raised to 4, here it will extend, plus x4 and Euler 4, so by 12, then plus x raised to 4 Euler raised to x upon 12. Now see, these two are similar, and they have the same, denominator. So this minus is not belonging to this expression. This minus is for all of them. So I put here plus, and I can call this one minus. Just you can let this one like this. So now what you have to do to solve this equation. Okay, this will be x raised to 3 Euler raised to x, 2, and here it will be plus minus 4 x raised to 3 Euler raised to x upon 12. Then this minus and this will be minus x raised to 4 Euler raised to x upon 12. And here plus the same expression, x raised to 4 Euler raised to x. No space here, so where should I find place for here? It's okay. Let me erase this one. Sorry. So yp will be x raised to 3 Euler raised to x by 2 minus 4x raised to 3 Euler raised to x 12 plus, minus again, minus x raised to 4, this one by 12 plus x raised to 4 Euler raised to x by 12. This and this will be cancelled out, so yp will be this expression. Okay, this one you can just find the common denominator. Okay, this will be 6, this will be this will be 2 x raised to 3 Euler raised to x upon 12. Okay, now this and this you can cancel out, so it will be 6 only. Okay, so this is your yp. Now put together your yp and your yc, and that is finished. Okay, this is your yp, your yc, and this is your yc. Now see, this is one way to solve this exercise. Okay, you can also solve this exercise by applying a different method or a different approach. Okay, so yeah, the most important thing here is to see x Euler to this one, so just follow the rule. This one, this is fine. As this guy is repeated 2 times, so x raised to 2, then repeat this guy 1 time. then x this guy, x raised to 3. Nice. Now for this part over here, what you have to do, this is repeated 2 times, then 2 times. So it means that I have to multiply by x raised to 4, and I have to derive this guy 4 times also. And doing this, you are going to have this guy. You derive this guy 4 times, you got 22. So 24. 24 and these 2, you are canceled out, you get here 12. X raised to 4, 12, this is minus, and this is okay till there. Now what you're going to do, this time this. So this time this, you will apply this guy, this function, into this operator, differentiation operator, and you apply to this guy also. To this one, minus and minus will be positive and will be the same by 12. And this one to this guy will be this one. So here you have to apply the product rule for differentiation. So the product rule is over there, okay? Minus is here. When you derive, first you derive x raised to 4, Euler raised to x will remain the same. Then you do not derive x raised to 4 and you derive Euler raised to x, that is the same. So it will be here. And this part is over there. Then just doing some basic addition of fraction, you are going to realize that this guy will be cancelled out with this, and here find the common denominator, and it is fine. So even here, there was no need to put here 6. Yeah, it should be only 3. But anyway, 6 is okay. Sorry. Yeah. 6. So here by 6, 6 minus 4, 2. 2x raised to 3, Euler raised to x upon 12. 2 and 12 will get this 1, 6. So this is yp, and this is this. Done. Okay. You can solve also this exercise in a by using case number 4. Okay. In the case number 4, you can use also this one. You can solve this one by case number 4. The question is how. I will give you just a hint, then you can just solve by yourself and find what is the most simple for you, or the simpler exercise for you. See, we have yp is equal to 1 upon d squared minus 2d plus 1, right? And it is x Euler raised to x. So in case number 4, we have to make this one alone. Euler raised to x, and then this one must be the function. This will be considered as g of x. So we will get this one, d squared minus 2d plus 1, okay? Then x, just like this, okay? For this case, we know, okay, what we have to do. We have to add. Where you find d, you have to put Euler, you have to put what? The coefficient of this x, that is 1. So it will be Euler raised to x, okay? Raised to x, and here 1, and here you get d plus 1 square minus 2d plus 1 and plus 1, all time x. Okay? Now from here, just solve these guys. What will it be? It will be d plus 1, this will be d square, Euler raised to x. This will be d square, and here it will be plus 2d minus 2d, 0. Then 1 minus 1, minus 1. So it will be d minus 1 times x. Okay? Times x. So in this way, you can just solve this one. Euler raised to x, okay? And here, Euler raised to x, okay? Here, what you have to do, this function must be looking like case number 3 here. You have to make this function look like this. 1 plus or minus f of d times x raised to m. When it is like this, so we know how to do, or we know what to do. Just apply case number 3. You are going to have what? Sorry. You are going to have this expression. 1 minus d square. Okay? Take just common this negative sign. So put here minus. And here apply for x. So what will it be? It will be Euler negative raised to x. Okay? Now apply this guy. Yeah, just apply this one to this. And yeah. You are going to get your previous solution directly. This expression right here, if you applied, what you are going to have, this is x, 1 upon 1, d square, this is x. So applying to this will be 1. If it is negative, plus f of d Okay, f of d is d square. Okay, then if you go now, okay, d square, this will be d square. Okay, yeah, d square plus d raised to 4 and so on. As you are applying for x, so there is no need to go further, these guys. Okay, so if you put this one, this, you apply here 0, 0, 0, it will be only minus Euler raised to x times x. But actually, this doesn't work. Sorry guys, I just thought you could solve by this method, okay? I just thought. But anyway, you just go for this one, okay? This is the clear one, and this is the most applicable, okay? Sorry, it doesn't work, actually. Didn't work. Okay, okay. Nice, so what is the next case, the next exercise? So here we have this one. The next exercise, or the next question is, this one is done. Now we are going to go for this one, for this guy, the giant on the village. Okay. Okay. So let's go. Okay. This is solved. Now that this is solved, let us solve for a different one, okay? A different one. So now we have this expression here, okay? This one. I will write here, it's d square plus 2d, okay? Y equal to Euler, then this guy, x times Euler, then sine of x. Okay? And that's the question, how to solve this one. Okay, as we know, just go for the, just follow the pattern. Can I use this one? Can I erase this one? I can erase this one, surely. Just go for the pattern, like this is Euler raised to x, like this, okay? Now go. This one, as you can see, this is x times g of x. Here your g of x will be all this function. It is x only. Okay? So yc will be Euler raised to 0x times c1 plus Euler raised to minus 2x times c2. Just basically making this equal to 0, you find what is d, then put d here, and that is fine. So what will be my yp? What will be yp? So yp here will be 1 upon f of d square plus 2d times x Euler x sinus of x. So we will apply case number 5. Okay? Yeah, case number 5. So how to solve this one? First, your yp will be equal to x times 1 upon function of d square plus 2d, then Euler x, and here sine of x, minus this function derived up, it will be 2d plus 2, then 1 upon the same function square, d square plus 2d square, then g of x, that is Euler raised to x, and here sine of x. Okay? Now see this expression over here, what you have here, that this expression there. So what you have to do, see, this case is case number 4. This is case number 4. Whenever we have, okay, here we have to apply 2 cases for solving this exercise. Case number 5 first, then case number 4. Or you can do the opposite if you feel like, but let us see. Here you have Euler raised to ax and g of x. Okay, when you have something like this, so your yp is equal to 1 upon f of d plus a times g of x. Okay, and put Euler out of the problem. Put here this guy out of the problem and let him like this. This is what we are going to do here. So yp will be x time, put Euler out of the problem, x times Euler. Then it will be 1 upon, where you find d, you put d plus 1. Where is coming this 1? From here. Square, okay, this will be d plus 1 square, plus 2d plus 1. Okay? This is all sinus of x. Okay? Now let's go for the second term, like this is with 2d plus 2. Now here, put the same, like d plus square and so on. D plus 1 square plus 2d plus 1. The same. Square. All is square. Then here, sine of x. Euler must be out of the problem, so do not forget this is 2d plus 2 and Euler out of the problem. So it means that you are going to apply just for this. Okay? Now see, from here what you have to do. This is the same, just keep it as it is. Now just solve these guys. Okay, solving this guy will be d squared plus 2d plus 2d, it will be 4d squared plus 4d, and here 1 plus d, this will be plus 3, and this is sinus of x, minus 2d plus 2 Euler raised to x, okay, time, the same here will happen, so it will be 1 upon d squared plus 4d plus 3. All it is square, and here it is sine of x. Nice. So what's the next step here? Here it is 1. Okay. The next step here is just to apply this. Case number 2. Okay? Put here minus 1 in the place of d square. Minus 1 square in the place of d square. Minus 1 square in the place of d square. Yeah, and this will be x, Euler raised to x. It will be 1 upon minus 1 plus 4d plus 3. So this and this, you can just simplify this. Minus 1 plus 3, it will be 2. So 4d plus 2 sine of x. And the same, minus d, 2d plus 2 Euler raised to x, and here you take like it will be 1 upon the same 4d plus 2 square sinus of x. Okay, till here it's fine, it's okay. Now see, this expression here, it is sinus, so we have to apply the second case. To apply the second case, this guy must be square, so you have to make it square. So, but before this, you can just simplify this guy, take this common 2 and put here out. So it will be x, Euler raised to x upon 2. Then multiply by, it's like if you take this guy, it will be 2 and it will be 1. And this 2 is here. Nice. Then multiply and divide by the conjugate. It will be what? 2d minus 1 upon 4d squared minus 1. Minus 1 sinus of x. Okay? Sinus of x. Then minus 2d plus 2. And here, just if you look at this, yeah, you will get something like this. Euler raised to x. And here you get 1. Just multiply. Just find this one. Okay? Just split it. It will be 4d plus 2 square. This will be 16d square. Then plus 16d and plus 4. Okay? Just take common your 4, 4, 4, 4, 4. You are going to have 4d square plus 4d plus 1. Right? Yeah, take common 4 here and put out. You are going to have 4d square plus 4d and plus 1. And here it is sine of x. Okay? Just like this. So after doing this, so now you can just take minus 1, here it is 1, so minus 1 square in the place of d square. Minus 1 square in the place of d square. And that's fine. Finished. So x raised to Euler raised to x2, and this is 2. Here you are going to have 2d minus 1 sinus of x, and here put here minus 1, it will be minus 5. Okay? Then minus 2 and 2 you can cancel out, you get minus 2. d plus 1 Euler raised to x all upon 4. Sorry, all upon 2. And here you are going to have, just substitute here. If you put here minus 1, what you're going to have? You are going to have something like this. 1 minus 1, here it will be minus 1, minus 4 minus this. This will be 4d minus 3. Then sine of x. Here you have to work out yet. And here it is x 10 Euler raised to x. Then just find this guy here. This will be differentiation to this guy. This will be cosinus. So it will be 2 cosinus of x minus sine of x. Just like this. But the second expression will be what? For here, this is minus 4d, this guy, and so on and on. Right? What you have to do, apply here the conjugate. 4d plus 3. So that this guy can be 16, and here it can be square. And this will be 9. Then substitute here. Okay? This will be d plus 1 Euler raised to x. This guy. Okay? When you substitute here, you are going to have 4d plus 3. Okay? 4d plus 3. All multiplied by sinus of x. All divided by minus 16 and minus 9. Okay? Minus 16 minus 9 is minus 25. So minus and minus plus. So it will be, as here we have 2, so it will be 100. 25 times 2, it will be 50. Okay? Yeah, this is 50. Now you have to apply this guy to this and this guy to this. Just like this. Okay? Here it is already found. Euler raised to x, 10, and here it is 2 cos x minus sine of x, plus this expression, do this time, 2 times, like d plus 1, okay, Euler raised to x. Now here, what you have to do, you just to play this and this and this and this. This will be Euler out. Then for this one, differentiation of sinus is cosinus of x. Then this and this will be plus 3 sinus of x. Okay. Now, what you have here, you have again differentiation. So it means that you are going to differentiate this guy and differentiate this guy. Then repeat this guy and repeat this guy, just like this. Okay? This is a long case. Sorry. Let me write down up here. So yp is minus x Euler raised to x upon 10. And here it is 2 cos of x minus sinus of x plus this one. First I will apply this differentiation to this and to this. Okay? When I apply differentiation to this guy and to this guy, will be this one, this and this. Differentiation of this guy. So it will be Euler raised to x. So for Euler raised to x, cosinus will be sinus of x. This is this and this. Now in the second way will be plus 4 Euler of x and the same cos of x nothing changed. Okay, so nothing changed. It is by 50. All is by 50. Everything I will write here, it's by 50. Now for the second case, I will have to apply differentiation of this guy. Differentiation of Euler raised to x and 3x. So it will be plus Euler, this will be 3. First case, I will derive sinus. This will be cosinus of x. So Euler raised to x, cos of x. Then in the second case, I will derive cos of x. So it will be plus 3 Euler raised to x sine of x. Nothing will change. This is for this and this. Okay? Let me see if there is another. Okay. Now we have to repeat this and this. Just repeat as it is. So, and there's no space. But anyway, I will write here down. Plus, I will just repeat. Okay? The function as it is. This times this and this times this 1. Because here we have 1. So it will be repeated like this one time and this one time. So it will be 4 Euler raised to x sinus of x plus 3 Euler raised to x cos of x. Okay? Yeah, just like this. 3 Euler sinus. Okay. Sorry. It is cos. Okay, so it is cos. This is negative. Okay. Negative is here, it is plus. Yeah, sorry for this one. It is 4 Euler cos of x. And that one, for 3, it is sinus. Sine of x, all by 50. Right? So what you have to do now? Now, you're just to simplify. Okay? Okay, just simplify them. Simplify all of them. Okay? Just add them. Okay? Because these have the same denominator. When I add this and this, what am I getting here? See here, this and this, it's equal to 8, if I can see here. Okay, as I can see here, like this becoming cos, okay, cos, nice, and 3 sinus, right. So cos, right, okay. This one, for time, this is nice, for time Euler, okay. Okay, this was sinus, so becoming sinus, this is fine. Now see, add these guys, what you are going to have, yp is minus x Euler raised to x upon 10, 2 cos of x minus sinus of x. Then plus all of them, okay? If you add this minus Euler raised to 4x and this guy, sinus, okay? And this guy. Put sinus together, Euler raised to x sinus together. If you put them together, you get 4 minus 4, then sinus, minus 4, and this. This will be only one time repeated, negative. And this guy, this will be 2 times. So it will be 2 Euler x sine of x. Okay? Only 2. Now, this guy, 4, 3, and 4. What will it be? 4 times 4, 8. 8 plus 3, it is 11. Okay? So it will be 11. So plus 11 Euler raised to x cos of x. All by 50. All by 50. Okay? All by 50. So what you're going to have here, this will be minus x Euler raised to x by 10, 2 cos x minus sine of x, plus this here will be Euler raised to x upon 50. So this will be 2 sine of x plus 11 cos of x. This is your yp. Okay, yeah, this is your yp. Sometimes you gotta go these steps this way, okay? But you can solve also this exercise by applying undetermined coefficient and all those different methods. Okay, you can just go and solve it. And here, as you can see, you can even simplify or find the common denominator and do this one, but it's fine then. So as this is yp, so what will be my yc? Yc we have already found. This is Euler raised to 0, that is C1 plus Euler minus 2x C2. Okay? If you add them, you are going to have this, guys. Okay, guys, that's all. Hope you may understand, at least just understand, and make it easy to you. Okay? Thank you. See you when we see each other.